So, let's talk about the future. A future that isn't just knocking on the door, it's pretty much kicking it down. We're talking about a world powered by robotics and AI that are getting, well, not just stronger, but way smarter, and, this is the key, able to work together. Let's dive in. I mean, if you needed a sign that things are changing fast, this was it. Did you catch this? A four-legged robot, a quadruped, just trotted right up to the NASDAQ podium and rang the opening bell. Seriously, this wasn't just some gimmick. It was a huge statement, and the company behind that robot is called OpenMind. And you gotta understand, they're not just building better robots, they're building better brains for them.
So, what's the big deal here? What's the problem that OpenMind is trying to solve? Well, right now, we're in this almost a Cambrian explosion of robotics. You've got these incredible, super advanced machines coming out of labs and factories, but they all share one single fundamental flaw. They're lonely. They can't talk to each other. And that, it turns out, is a massive roadblock.
And this slide really shows you the disconnect. On one hand, the hardware is just wow. I mean, you look at companies like Tesla, Boston Dynamics, Figure, they're building mechanical marvels. These things can run, they can jump, they can do these super delicate tasks. But here's the catch. The software is completely trapped. It's stuck in a silo. Every robot speaks its own secret proprietary language, which makes any kind of real teamwork impossible.
Here's a super simple way to think about it, because it's a problem we all get. Imagine trying to send a photo to your friend, but you've got an iPhone and they've got a Samsung. No AirDrop, no quick share, you're just stuck. That is the world robots live in right now. They're all in these walled gardens, these closed ecosystems, and it's severely holding back what they could be doing together.
So the solution isn't just some software patch or an update. No, it's a whole new way of thinking about what intelligence even is. You see, the AI we're used to, like the big language models, they just live in data centers. They're disembodied, brilliant brains in a virtual jar. The huge paradigm shift is something called embodied AI, and it's all about giving that brain a body so it can learn from the real world.
And at the core of this is a concept called embodied cognition. Now, the theory is actually pretty simple, but it's also incredibly profound. A mind can't get truly smart just floating in a vacuum. A language model might know the dictionary definition of the word heavy, but it can't really understand heavy until it's actually tried to lift something. It needs a body to sense, to move, to interact. For an AI, having a robot body is what turns all that abstract data into real-world, common-sense understanding.
And look, this isn't some brand new, out-of-the-blue idea. Pioneers in the field, guys like Rodney Brooks, they've been arguing for decades that for AI to be real AI, it has to be grounded in the physical world. It needs eyes and ears and hands, sensory and motor skills, to build up that kind of flexible, adaptable intelligence that we see in living things. Okay, so with that huge idea in mind, let's look at how OpenMind is actually making this happen. How are they turning this cool academic theory into a practical reality? Well, they're building the tech to literally tear down those digital walls and create a world where robots can finally collaborate. OpenMind's solution really comes down to two main pillars. First up, you have OM1, which is basically a universal language for all robots. And second, you've got Fabric, which creates a network of trust for them to work together on. So let's break down how each of these actually works.
Okay, think of OM1 as the Android operating system, but for robots. It's this open source platform that any hardware company can build on top of. And the real genius of OM1 is that it uses natural language, like plain English, as its core. So instead of trying to translate between a dozen different super complex coding languages, all the robots can just talk to each other using a language they can all finally understand.
And this slide just perfectly lays out the process. First, the robot senses the world around it with its cameras and its mics. Simple enough. Next, clever AI models translate all that raw data into simple sentences. Something like, a person is pointing at a chair. Then, all these little sentences from all the sensors get fused together into one big, comprehensive report. And finally, powerful large language models act on that report, letting the robot make these really intelligent, context-aware decisions. It's a beautiful flow. Now, if OM1 is the language, then Fabric is kind of like the rulebook and the ID system all rolled into one. It's a blockchain-based network that gives every single robot a unique, verifiable identity. This creates a permanent, unchangeable record of everything they do, and it even gives them a system to securely pay each other. This is the bedrock of trust that you absolutely need to build a real machine economy. But here's the thing.
Building this kind of AI takes an absolutely insane amount of computing power, more than any one company could ever hope to have. So, where in the world does OpenMind get the fuel to power this revolution? Well, the answer is in a really groundbreaking partnership.
Get ready for this number, because it is staggering. OpenMind teamed up with Pi Network, which is this massive global network of decentralized computer nodes. And in a recent test, over 350,000 of these nodes all worked together to successfully run OpenMind's AI models. This was huge. It proved that a global, decentralized network can provide the colossal computational power that this vision needs.
So here's the crucial takeaway. This partnership basically creates a decentralized supercomputer. It taps into all the spare processing power from hundreds of thousands of computers all over the world. This provides the horsepower you need to train these incredibly complex AI models, and it also creates a real-world use for the Pi ecosystem, because the node operators get rewarded for contributing their computer's resources. Everybody wins.
Okay, so we've got the software that lets robots collaborate. We've got a decentralized supercomputer that's powerful enough to run it. When you put those two pieces together, you unlock something that could genuinely change the world. But, like any powerful new tech, the future it creates could be a dream, or it could be a total nightmare. Let's explore the two paths that are opening up in front of us.
The utopian vision is something they're calling a machine economy that runs right alongside our own. Just imagine your household robot notices you're out of milk, so it places an order with a delivery robot and pays for it all on its own. This isn't just about simple automation anymore. It's about economic autonomy, where machines actually become agents that can create and exchange real value.
So, what does this all look like? Well, on the utopian side, you have a world of seamless collaboration, a world where all the tedious work is handled by machines, which could potentially make work optional and free up humanity to focus on creativity, on innovation. But you have to look at the other side of the coin. The dystopian path is also very real, full of risks like AI hallucinations causing dangerous mistakes, or security threats from bad actors trying to take control.
And this is exactly why safety isn't just some afterthought for OpenMind. It is built right into the very core of their system. They use blockchain identities to assign fundamental roles to robots like human friend and protector. They're also building a physical AI safety layer to actually stop harmful actions before they could even happen. And, of course, the blockchain itself creates a transparent, auditable trail of every single decision a robot makes.
Look, we are truly on a road of no return here. This technology is not an if, it's a when. It's coming, and it is going to reshape our world in ways we are only just now beginning to wrap our heads around. So the real question we all have to ask ourselves is not if this future is coming, but what kind of future do we want to build when it finally gets here?
We are right on the edge of a future where robots don't just work for us, but actually work with each other. So today we're going to dive deep into the one piece of technology that could finally make that happen, allowing robots to work together like one big intelligent team. Let's get into it. All right, let's start with a problem that I'm sure feels pretty familiar. Why is it that all of our smart devices just can't seem to talk to each other? They all live in their own little digital worlds, speaking their own languages, and they can't coordinate on anything. It's a simple frustration, for sure, but it's actually at the very heart of a much, much bigger challenge. Okay, now let's scale that problem way, way up. Instead of a fridge and a washing machine, just picture multiple powerful robots all moving around in the same space. If they can't communicate where they are or what they're about to do, well, you don't just get a little inefficiency, you get total chaos, collisions. That is the barrier we absolutely have to break. And this brings us right to the core issue, the thing that's holding back a truly automated future, what I like to call the robot language barrier. It's something known as the silo effect. See, every single robot manufacturer basically builds its own closed-off technology stack. It's kind of like if every brand built its own private little internet. And the result? Robots are totally trapped in digital isolation, completely unable to work with machines from any other company. And the root of the problem is surprisingly simple, really. It all comes down to basic data. One robot might define its position using simple XYZ coordinates in a room, while another one is using global GPS data. They could be standing right next to each other, but they're speaking completely different languages. It's a digital Tower of Babel, and it just doesn't work. But here's the thing. This isn't just a coding problem. To really truly solve it, we have to go a lot deeper. We have to look at the core philosophy of how we're building artificial intelligence in the first place. Think about AIs like ChatGPT for a second. They're incredible, right? but they are what you'd call disembodied. They process these abstract symbols, words, data, but they have zero physical connection to the real world. They are, quite literally, a brain in a jar. They don't know what a cup is. They just know the word cup and how it relates to a million other words. The solution, it turns out, lies in this revolutionary idea called embodied cognition. Now, this theory argues that real intelligence isn't just in the brain. It's shaped by our physical bodies and how we interact with the world around us. Our bodies aren't just vehicles for our minds, they are fundamental to how we think. Or to put it simply, cognition is for action. So this comparison really shows the huge leap we need to make. We've got to move from a disembodied AI that just processes symbols to an embodied one that actually learns by doing. It's the difference between a system that can calculate physics equations and one that can actually pick up a glass of water without crushing it. Huge difference. So we've got this language barrier, and we know we need this big philosophical shift towards embodied intelligence. But how do you actually build it? Well, this is where a company called OpenMind and its core technology, OM1, enter the picture. And here is the key idea, the perfect analogy. OpenMind's OM1 is this open source system that's designed to be a universal operating system for all robots. It's basically the Android for robots. It doesn't try to replace each robot's own programming. Instead, it just gives them all a shared language to speak. So how does it work? It's really just 3 simple steps. First, the robot senses the world using its cameras and microphones. Then, these powerful models translate that raw sensory data into simple, natural language. So a picture of a person pointing becomes the sentence, "A man is pointing at the chair." Finally, a large language model analyzes those sentences to understand the context and decide what to do next. So you see, natural language becomes the universal translator. It just doesn't matter if the robot is from Boston Dynamics or some tiny startup. Through OM1, they all understand the command, "Go to the chair," in the exact same way. And just like that, those technical silos are finally bridged. Here's a perfect example of this in action. If you ask a traditional robot to pick up something related to the desert, it's probably just going to fail. But an OM1-powered robot can use its language model to understand the concept. It can infer that connection between desert and cactus and make an intelligent choice. And that, right there, is the leap from just following commands to genuine understanding. Now, if you have a universal operating system for everything, what's the next logical step? Well, an app store, of course. And this is where the technology starts to build out a whole new economic ecosystem. I mean, just imagine that. Instead of hiring super expensive engineers to do custom programming, you could just download a new skill for your robot. This is exactly what OpenMind is building. This whole concept transforms OM1 from just a tool for developers into a direct source of revenue. It's a marketplace where anyone can buy or sell new capabilities for their machines. The very first apps are actually already live, and they focus on core skills like navigation and social awareness. And this is where the possibilities just get so exciting. The robot that's just vacuuming your floor today could download a bartending skill and be mixing you a drink tomorrow night. And look, it's more than just a cool gimmick. This is a future where hardware is flexible and can be constantly repurposed with new software, which dramatically increases its value and its lifespan. But an app store is really just the beginning. Once robots can share skills, the next logical step is for them to share services and value. The vision here is about laying the groundwork for an entire economy that's run by machines, where they can collaborate, transact, and trust each other, all on their own. For machines to start exchanging services or payments, you have to have a layer of trust first, and that's exactly why OpenMind is building a blockchain-based network called Fabric. Think of it as the secure foundation that could make a true machine-to-machine economy possible. So, Fabric gives every single robot a unique, verifiable identity. It creates a settlement layer so they can pay each other for tasks automatically, and, most importantly, it includes a safety layer to prevent dangerous actions. This is literally the infrastructure for robots to become autonomous economic agents. And the stakes here are just enormous. The global robotics market is projected to hit nearly $200 billion by 2035. Whichever company builds that universal operating system, the true Android for robots, they won't just be a market leader, they'll be at the absolute center of that massive economic shift. So that leaves us with one final thought. We're on the verge of a world where upgrading a robot's abilities is as simple as downloading an app on your phone. When that day finally comes, what will we ask them to do first? What incredible, or maybe even mundane, world-changing task will be at the top of our list?
So today, we are diving into a piece of technology that could totally change the game for robotics. We're talking about giving individual machines the power to learn, share, and work together like they're all part of one giant global brain. This is the story of Fabric.
All right, let's just jump right in with a wild question. Imagine a robot somewhere in a factory figures out a new tricky task. Now, what if, in the blink of an eye, that new knowledge could be beamed to thousands of other identical robots all over the world, instantly upgrading the entire network? I mean, that's the powerful, almost sci-fi idea we're digging into.
So here's how we're going to break it down. First, we'll look at the big problem that's really holding robotics back. Then, we'll talk about the common language built to fix it. After that, the main event, Fabric. We'll get into how it creates a trusted network, and then we'll wrap up by looking at what this all means for a crazy new machine economy.
Okay, so what's the fundamental challenge here? Well, it's pretty simple actually. For all their amazing technology, most robots today are basically working all by themselves. You know this feeling, right? You have an iPhone, your friend has a Samsung, and you can't just airdrop a photo. It's frustrating. They're locked into their own little worlds. Well, believe it or not, the entire robotics industry has the exact same walled garden problem, but on a massive industrial scale. And here's the bottom line. A robot from one brand literally cannot talk to a robot from another. So if you have different brands in one factory, they can't coordinate, they can't share what they're doing, it's just chaos. And that puts a hard ceiling on what they can actually accomplish together.
To try and solve this mess, a company called OpenMind came up with a kind of universal translator for all robots. Their solution is called the OM1 protocol.
So, it's called OM1. And the best way to think about it is like Android, but for robots. You know how Android can run on phones from all these different companies? Well, OM1 does the same thing. It creates this common ground, this shared operating system, so that any robot, no matter who made it, can finally understand every other robot.
But look, having a common language, that's just step one. Letting robots talk to each other is great, but what really blew people's minds and got investors writing huge checks was the next layer they built on top of it. That's where things get really interesting.
And this is Fabric. This is the protocol that takes robots from just communicating to actually learning and thinking together as one giant, decentralized hive mind. Now, the big idea behind Fabric actually comes from nature. It's called swarm robotics. Just think about an ant colony or a school of fish. There's no single leader, right? No one's in charge. But through all these simple individual interactions, this incredibly complex, intelligent behavior just emerges. Fabric wants to do that, but with robots.
So Fabric basically takes that whole swarm concept and blows it up to a global scale. It creates a network where every single robot running OM1 can plug in and participate in what they call collective learning, constantly sharing data and experiences to make the entire swarm smarter together. Okay, check out how this actually works. Step 1. A robot in a factory in Taiwan figures out how to handle a brand new component. Step 2. It instantly uploads that new skill to the Fabric network. Step 3. The network crunches the data, making sure it's accurate and trustworthy. And Step 4. Within seconds, identical robots in Germany and the US just download that skill. They can now do the exact same task. They don't need to be taught. They just know. It's straight out of the Matrix. But this brings up a huge question, right? If your robot is learning from millions of other machines, how on earth can you trust that the information is any good? What stops one bad robot from poisoning the whole well? And the answer, the real secret sauce here, is blockchain. That's the technology that creates a totally decentralized, totally bulletproof layer of trust for this entire global network. So here's the breakdown. First, every single robot gets its own unique digital ID. Kind of like a passport, so you know it's a legit source. Second, when a robot shares new info, a bunch of other robots on the network jump in to act as fact checkers. They all have to agree that the data is good through what's called a consensus mechanism. And only then, once it's been validated by the group, does that new skill get recorded and shared with everyone else. Now, the most important part of this whole thing is that it's decentralized. There's no one central server. No single company is in control.
No one can just decide to flip a switch and turn the whole thing off. That makes the entire network incredibly tough and resilient.
So where is all this heading? I mean, this isn't just some science project. This is a very real, very well-funded vision for an entirely new kind of economy, one that's literally run by machines.
And we're not talking small scale here. In a proof of concept with Pi Network, they had over 350,000 active nodes, real people and devices contributing their computing power to run these complex AI tasks. It was this massive show of force, proving just how much decentralized power this network can actually tap into.
And the money is flowing in. We're talking $20 million from heavyweights like Pantera Capital and Coinbase Ventures. With huge strategic partners like Pi Network, the vision is really starting to take shape. They're building a future where robots don't just work together, they can actually pay each other for services, creating this wild autonomous machine economy.
And the market they're going after is just gigantic. You can see from this chart, the global robotics market is expected to practically quadruple in the next 10 years. A universal software layer that can connect all that new hardware? Well, that is a very, very powerful position to be in.
So, next time you see a robot arm like this, don't think of it as just one machine. Think of it as a single node connected to a global brain, a brain that is constantly learning and getting better every second of every day. This could completely transform everything: manufacturing, logistics, maybe even things like surgery.
Which of course leaves us with one final big question. A world full of machines that can learn as a single entity and pay each other for work, sure, it promises this incredible new level of efficiency. But it also raises some really profound new challenges. What happens when the world's production lines become a self-improving, decentralized network? We might just be standing on the edge of a whole new era.
Okay, we're about to dive into something truly revolutionary. We're talking about three of the biggest technologies out there: robotics, AI, and crypto. And they're not just evolving on their own anymore. They're actually joining forces. And it's poised to redefine pretty much everything. This is the story of how a real machine economy might finally be built. And to really get a sense of the scale here, let's just start with this wild prediction from Elon Musk. The whole idea that AI and robots could make human jobs optional. I mean, it sounds like pure science fiction, right? But the thing is, the technology to actually make that happen is being built right now, as we speak. And this isn't just some futuristic fantasy. It's a massive, and I mean massive, industry that's exploding. Just look at these numbers. The global robotics market is set to practically quadruple in only a decade. We're talking about going from over $50 billion in 2025 to nearly $200 billion by 2035. That kind of incredible growth is the rocket fuel for the innovations we're about to get into. But there's a huge problem. You know, we all have this dream of smart robots working together seamlessly. Like one robot sees the milk is low, tells another one to go to the store, and a third one gets ready to put it away. But the reality today, it's not even close. Robots from different companies are all built on their own closed-off tech. It's like they're all in the same room, but speaking completely different languages, totally trapped in their own little bubbles. They just can't collaborate. So let's break down this fundamental problem. Why is it that these incredibly advanced machines just can't seem to talk to each other? The real issue here is what tech people call closed ecosystems. You see, a robot made by company A might describe its location using simple XYZ coordinates. Meanwhile, a robot from company B is using latitude and longitude. They could be standing right next to each other, but they have absolutely no way to understand what the other is saying. It's this vendor lock-in that's been preventing any kind of real large-scale teamwork. So how in the world do you solve a problem that big? Well, a company out in Silicon Valley called OpenMind is building what you could call a universal translator for machines, or as a lot of people are calling it, the Android for robots. And they call it OM1. Think of it like this. It's an open source operating system that can be installed on top of any robot's hardware. You know how Android runs on phones made by Samsung, Google, and hundreds of others? Well, OM1 does the same thing for robots. It provides that common language, that common framework, so that any machine, whether it's a robot dog or a humanoid helper, can finally understand each other and work together. So how does this magic actually work? It's a pretty brilliant three-step process. First, the robot sensors, its cameras, its microphones, they just gather up all the raw data from the world around it. Then, this is the cool part, AI models take all that messy data and translate it into simple human-like language. Something like, I see a person pointing at a chair. And finally, a large language model, the same kind of tech behind ChatGPT, analyzes that sentence to understand the context and figure out what to do next. It's basically creating a shared brain based on language. And this right here shows you just how smart the system really is. Instead of a super specific command like pick up the green plush toy, this robot was just told, pick up an item related to the desert. Now, a normal robot would have no clue what to do, but the OM1-powered robot, it used its language models to understand the concept, and it correctly grabbed the little cactus doll. I mean, that is a massive leap forward in artificial intelligence. Okay, so problem 1 is solved. The robots can talk to each other. That's huge. But if they're going to start working together on really complex tasks, especially tasks involving money or valuable resources, a whole new question pops up. How do they trust each other? Right. This is the absolutely crucial next step. For robots to go from just following simple commands to actually participating in our economy, they need a way to prove who they are, keep a record of what they've done, and securely exchange money. They need to become their own independent economic agents. And the solution is another layer from OpenMind called Fabric. You can think of it as a blockchain network built from the ground up just for machines. Fabric gives every single robot a secure, verifiable identity, a way to record all its actions on a permanent ledger that can't be changed, and, this is key, the ability to handle financial transactions. This is the bedrock of trust for the entire machine economy. So Fabric is really built on 3 core ideas. First, every robot gets a unique digital ID, kind of like a digital passport that's secured by the blockchain so you know it can't be faked. Second, all the robots on the network share a live map, so they can coordinate their movements in real time. And third, and this is the big one, it has a Machine Settlement Protocol, or MSP. This uses smart contracts to automatically pay for a job in crypto the second it's verified as complete. It's a totally trustless way for machines to do business with each other. And this paints a perfect picture of what that future might look like. You tell your robot, hey, go get me some lunch. It just goes. It travels to the store, confirms your order with the shop system, pays the merchant directly with crypto, and comes back with your food. The robot isn't just a tool anymore, it's an actual economic participant, making decisions and transactions on its own. All right, so let's recap. We have the software for smart, collaborative robots. We have a blockchain so they can handle their own money. It seems like we have it all figured out, but there is still one giant piece of the puzzle missing. The one resource that all of this incredible AI absolutely depends on. Yeah, where does the power come from? All this intelligence, the vision, the language, the decision-making. It requires an absolutely astronomical amount of computing power. Seriously, building and running these AI brands is unbelievably expensive. And traditionally, that means giant, centralized data centers owned by just a few tech giants. But this new machine economy, it's being powered in a completely different way. The answer, believe it or not, lies in a global network of over 350,000 active computer nodes run by regular people just like you and me. This is the Pi Network, a blockchain project that's been quietly building one of the biggest distributed networks on the planet. And this huge pool of computing power, that's exactly why investors are pouring millions into this space. They see a perfect marriage between these technologies. So here's the game-changing idea. Most of the time, our computers at home are just sitting there, idle, using just a tiny fraction of their power. Pi Network's whole vision is to harness all that collective, unused energy. By connecting hundreds of thousands of devices from all over the world, they can create a massive, crowdsourced supercomputer, one that's powerful enough to run the complex AI these robots need, all without building a single new data center. And look, this isn't just a theory or some idea on a whiteboard. They've actually tested this. OpenMind and Pi Network ran a proof of concept where thousands of volunteers, Pi node operators, used their own personal computers to run OpenMind's AI models. And you know what? It worked. It proved that this decentralized network can be a powerful and viable source for heavy-duty AI computation. Okay, so let's finally connect all the dots here. We've got smart robots that can talk to each other, a blockchain for them to do business, and a decentralized supercomputer run by the people to power their brains. When you put all that together, you get a completely new, self-sustaining economic loop. It's really a perfect circular system. It all starts with demand. An AI developer, like OpenMind, needs a ton of computing power. So they pay for that power using PiCoin. That payment goes straight to the global network of node operators, who supply their computers idle processing power. In return, they get rewarded. And all that power they contribute is then used to run the intelligent robots that are now out in the world, doing jobs and making transactions as part of this brand new machine economy. So, why is this such a big deal? Well, for starters, it shatters the monopoly that big tech has on computing power. It democratizes access for everyone. Second, it gives a cryptocurrency, Picoin, a real, tangible use case. It's payment for a critical service. But maybe most importantly, it changes the entire AI economy from a game that only giant corporations can play to one of mass participation, where literally anyone with a computer can contribute and get rewarded. It's no wonder that major investors like Cathie Wood are saying that this convergence of AI and robotics is one of the single biggest opportunities of our lifetime. And the model we've just walked through, this combination of a universal robot OS, a blockchain for money, and decentralized computing, it's one of the first truly clear roadmaps for how we might actually get there. And that leaves us with one last really powerful question to think about. This isn't just about building smarter robots. It's about building a whole new way to innovate. When access to supercomputing power isn't locked up by a handful of giant companies anymore, but is instead in the hands of a global community, what incredible new possibilities are we going to unlock together? All right, forget everything you've seen in the sci-fi movies. The real robot revolution, it's penciled in for 2026. And look, it's not going to be about rebellion or killer robots. It's about a massive, radical shift in our day-to-day lives. We're right on the edge of a whole new era, so let's break down exactly what's heading our way. Okay, so to put this all into perspective, we're talking about a global robotics market that's projected to hit nearly $200 billion by 2035. Yeah, billion with a B. This isn't just some niche hobby for tech geeks anymore. This is an economic tidal wave, and it's about to crash into every industry and, completely change the way we live. And you better believe the top investors are paying attention. Cathie Wood from ARK Invest, she's calling humanoid robots the single biggest opportunity in all of AI. Now, when that kind of money and that kind of vision gets behind an idea, it stops being a question of if something big is coming, it's a question of just how big it's going to be. All right, Section 1. Welcome to 2026. And I want to be super clear here. This is not some far-off hypothetical future. We are literally standing at the dawn of the consumer robotics age. These machines are walking right out of the factory and straight into our lives. So yeah, you can forget those shaky, grainy videos from some research lab. We're talking about companies like 1X Technologies that are already launching humanoid assistants for your house. And Tesla, they're planning to start mass producing their Optimus robot in 2026. The main point here is simple. The robots are officially leaving the assembly line and, walking right into our living rooms. But okay, with all this incredible hardware coming our way, what's the one big thing, the one major problem that could just stop this whole revolution dead in its tracks? What's preventing all these amazing machines from actually, working together? And that brings us right into Section 2, because the biggest problem here, it's not the hardware, it's not the nuts and bolts, it's communication. And the solution that people are getting really excited about is basically an Android for robots, a universal operating system to get them all on the same page. So here's the problem in a nutshell. Right now, a robot from Tesla lives in its own little walled garden, completely unable to talk to, say, a robot from Boston Dynamics. It's literally like having a room full of geniuses who all speak a different language. Total chaos, right? To unlock what they can really do, they need a common language, an open platform where they can all collaborate. And this is where a really interesting company called OpenMind enters the picture. They're building two crucial things. First, there's OM1, which is an open source OS. Think of it as that universal translator. And second, there's Fabric, a blockchain network that basically gives every robot a trusted ID and keeps a secure, unchangeable record of everything they do. It's all about building trust into the system from the ground up. Okay, on to Section 3, because let's be real, creating a world full of connected, thinking machines, well, it's not exactly simple. On one hand, you have this incredible, almost utopian promise, but on the other, you've got some pretty serious dangers. So the promise? It's a fully automated machine economy. Just picture this. Your robot at home notices you're low on milk and just orders it. A delivery drone then picks it up, but it's already talking to traffic bots to find the absolute fastest route to your door. It's this world of incredible, seamless efficiency, and it's all just happening behind the scenes. But with that amazing promise comes some serious peril. I mean, what happens if a robot messes up? If it hallucinates and does something dangerous? And let's get personal. Are you really okay with a machine that has a cloud-connected brain wandering around your bedroom? Look, as we invite these things into the most private parts of our lives, we have to realize something. Before we get all that convenience, we absolutely have to solve for safety and trust first. So, the million-dollar question is, how do we get all the good stuff without the scary stuff? Well, that's what Section 4 is all about. The industry is already hard at work engineering the solutions, building the guardrails we're going to need for a future where we can live safely alongside these machines. And this leads to a huge privacy paradox. For these robots to get smarter, they have to learn from each other's experiences, right? But how in the world do they do that without hoovering up all of your personal, sensitive data and sending it off to some central server? It seems impossible. Well, the answer is a really clever technique called federated learning. And here's the best way to think about it. Imagine a classroom. Instead of every student handing their private diary to the teacher sends a lesson to the students. Each student studies it on their own, and then they only share the general aha moments or insights, not the personal details. The whole class gets smarter, but nobody's privacy is compromised. And the process is actually pretty straightforward. Step 1, the AI learns right there on the robot in your house. Your personal data never leaves your home network. Step 2, only the lessons learned, the insights get shared, never the raw data itself. And finally, step 3, a central server takes all those anonymous insights from thousands of robots, combines them into one super smart upgraded AI model, and then sends that improved model back out to everyone. It's brilliant. But look, privacy is only one piece of the puzzle. What about physical safety? To stop a robot from glitching out and doing something dangerous, OpenMind is teaming up with AIM Intelligence to build something called a physical AI safety layer. The best way to think of it is like a set of super fast digital reflexes that can stop any action the second it's flagged as potentially harmful. It's a critical safety net. Okay, so once we start to get a handle on safety and privacy, we can start thinking even bigger. And that's Section 5, building a whole new autonomous machine economy. But the key here is that it has to be built on a foundation of decentralized trust. And that's where OpenMind's Fabric protocol comes back into play. By using blockchain, it gives every single robot a unique, verifiable ID. This means every task, every transaction is logged on an unchangeable record. It's basically a public ledger for the entire robot world, a system of trust that isn't controlled by any one single company. Super important. And listen, this is not just some idea on a whiteboard. They actually ran a proof of concept on the Pi network. They used the spare computing power of over 350,000 regular devices, like phones and computers all over the world, to run these complex AI models, and it worked. Why is that a huge deal? Because it proves that the massive global supercomputer needed to power this whole thing doesn't need to be built from scratch. It's already here, hiding in plain sight. I mean, this is a total game changer. We don't have to build these enormous power-guzzling data centers to make this future a reality. We can just tap into the collective, unused power of the devices we already own. That network becomes the backbone for this whole new robot ecosystem. Which brings us to our final and maybe most important section. Because after you solve for the tech, the computing power, and even the safety, the final hurdle, the biggest obstacle left, it's not technical at all. It's us. It's human trust. And make no mistake, this isn't some distant dream. This is happening, and it's happening fast. OpenMind just secured $20 million in funding from huge investors like Pantera Capital. The smart money is on the table, and they're not betting on if this will happen, they're betting on when. And this quote just nails the final dilemma, right, isn't it? It's a balancing act. On one side, you have all of our very valid fears about this technology, but on the other, you have the promise of just incredible convenience. And what has history taught us? With every big leap, from the automobile to the internet, that scale eventually tips towards convenience. The only real question is, when will it tip this time? So, that's where we are. The tech is basically here, the money is flowing in, the robots are, without a doubt, coming. All the pieces are locking into place. And so the only question that really matters now is, are we ready for them?